Bienvenidos, Ushamadid, and welcome UMGC learners from the CMIT-455 Section 6380 course for the Spring 2021 semester. This is the CCNP ENCOR version 8 course from the Cisco Networking Academy curriculum, and in this supplemental tutorial video, we're going to be taking a look at another topic that came up in Chapter 16, and that was configuring Site-to-Site IPsec VPN tunnels. Now, we've been building over the last 3 or 4 videos up to this point right here, where we're going to talk about how you would want to set up site-to-site IPsec tunnels using static virtual tunnel interfaces. Remember, we wouldn't want to be using crypto maps. Those are kind of legacy, although there may be a use case in there somewhere. And then you had GRE over IPsec, and we saw how that worked out, and we also had the crypto map involved there. And then we transitioned to the static virtual tunnel interfaces. The whole time in the previous videos, we've been using Ike V2, or the Internet Key Exchange Protocol. And remember that Ike uses ISAMKP, which is that Internet Security, Automation Key Management Protocol, to do the key negotiation. And so we talked a lot about Ike version 1. So here you're going to see Ike version 2. And again, for greenfield deployments, you should probably be using Ike version 2 or Ike V2. Now, there are fewer packets that get exchanged, right? Remember when we talked about Ike V1, we had main mode, we had aggressive mode, and then you had the quiet mode. Well, here, when we're working with Ike V2, you're going to have what's called the Ike SA init, the Security Association Initialization. And typically, you're going to end up with about 4 packets. And so it's a little different than if you looked at a main mode with the 6 packets, or even the aggressive mode with the 3 packets, and then you had the quiet mode packets onto that. So you've got the Ike SA init, and then you're going to have an Ike auth message, a create child SA. So there's going to be sort of a different way to make this configuration happen, and I like it because I feel that there's a little more configuration, but it definitely allows you some additional flexibility. And so we'll work with combined mode ciphers here in terms of what we're going to be setting up. And so then this would be sort of your quote unquote next gen encryption, your NGE configuration that would provide you sort of with the best setup possible given the iOS version that we're running. So let's go ahead and jump over to Cisco Modeling Labs. And again, you should be very familiar with this topology here. This is our cloud, our internet ISP, and you've got router 1 in California and router 2 out in New York. And so PCA, as you can see, cannot ping PCB, right? We don't have anything working between the 2 sites, and PCB can't ping PCA. So where do we start? How are we going to begin? So with Ike V1, and I'm going to draw a lot of references and analogies with Ike V1 when we go to set these things up. And so remember, we would talk about phase 1 and phase 2. And so I'm going to continue to kind of talk about it like that, even though there's sort of like not sort of that, clear cut like that right there is phase 1 and that right there is phase 2. So there's a little bit more configuration work that's going to go into what we're doing, but I think you'll see that it sets up nicely here. So let's go ahead and get onto the command line. Let's go from user exec into privilege exec into global config. And the command syntax is one thing that I really like. So when we're working with Ike V2, it's crypto Ike V2. And it's pretty much crypto Ike V2 for just about everything we're going to be doing here that would be part of sort of like your phase 1 configuration, right? We're going to be protecting that keying material. And remember, with Ike V2, the authentication is unidirectional. And what that means is that I can set a password, a pre-shared key password on router 1, and then set a different pre-shared key password on router 2. And as long as I have that defined under my keyring, and we're going to be creating a keyring, we're going to be good to go. And so let's see what that looks like. So I'm going to say crypto Ike V2, and if I do a question mark, you can see we've got all kinds of different options here. We're interested in the proposal, and I'm going to walk through these as they would show up in our running config. And then all we're going to put here is the name of the proposal. And so this is the California router, so I'll say CA-2-NY-prop, right? So this will be our proposal. Now, you're also going to see things like this, where it's going to come up and it's going to explain to you or give you sort of a cue that, hey, don't forget to do this, or you need to do this, or as you're going to see when I get ready to run some commands here, hey, you can't or don't need to choose an integrity protocol because you've chosen a combined mode cipher. And I used a combined mode cipher in the previous video, but again, failed to mention that instead of a sort of a normal mode cipher, if you will, which would be the aes-CBC type ciphers, we're going to be using aes-gcm, right? And we'll also use the same thing when we go to do our Diffie-Hellman configuration as well. So in the proposal area, this should look pretty familiar. Well, what do we have here? Well, we've got the encryption setting, the Diffie-Hellman group setting, the integrity, right? So encryption is the C in the CIA for confidentiality. We've got our Diffie-Hellman group setting. That's the A, the authentication that's using Ike for that secure key exchange. Diffie-Hellman makes that happen. And then we've got our I, which is the integrity. And now we've got this new setting as well, which you'll see is referenced here is PRF, and that's the pseudo-random. It stands for pseudo-random algorithm, right? And that's what that's the PRF, pseudo-random algorithm. So we're going to be adding that in as well. So let's go ahead and knock this out. So we're going to say encryption, and here is where we're going to use aes-gcm 256. Again, if I was to refer to the next gen encryption document, you can see right here, that is considered next generation encryption, right? Whereas when I was using the 256-bit for the AES-CBC, right, it was considered acceptable. So we're going to make sure that this is airtight in terms of the encryption settings that we're using. So AES-GCM 256-bit, right, quantum computing resistant, we'll put a check mark on that. And I'm going to talk about, we'll talk about Diffie-Hellman and whether Diffie-Hellman is quantum computing resistant or not. And spoiler alert, it's not. So I could put an additional setting here, right? Because again, maybe the other side can do AES-GCM 128, but can't do 256. And so they would sort that out. But here, since we're in control of pretty much everything, we're just going to say encryption AES-GCM 256. Now, the note that the information I said earlier, right? This is considered to be a combined mode cipher, right? And a combined mode cipher combines both the confidentiality, the encryption, and the integrity, right? The hashing, that sort of check to make sure that nothing's been tampered with in transit. And so the combined mode ciphers do not require me to pick an integrity hash. And watch what happens when you do. If I was to say integrity, and we obviously want to go for SHA-512, right? Because we're making sure that we're doing the best thing we can. You're going to get a message here telling you they're not allowed when you're using the AES encryption algorithm, which is GCM, which is a combined mode algorithm. That's not a normal mode cipher. It's a combined mode cipher. In fact, CM, think of it as combined mode, right? So we don't have to do the hashing setting because it's taken care of for us. And again, quantum computing resistant. So the encryption's done. The integrity piece is done because it's built into the GCM algorithm we've chosen. So now we need the Diffie-Hellman group. So when we do the group listing, you can see I'd commented earlier, yeah, typically the higher number is better. However, here, Cisco best practice recommendation is to use Diffie-Hellman group 21, which is using the elliptical curve cryptography. And that is considered to be better than group 24. And so we're going to use group 21. Now, the question is are these Diffie-Hellman groups quantum computing resistant? And again, they are not. But this is by and far the best choice that we can make. Now, the final setting that we're going to have to take care of here is going to be the PRF. And so this is that pseudo-random hash algorithm. And so we'll go with SHA-512 here. And that is sort of equivalent to when we would do the crypto ISAMKP policy setup, right? When we're trying to protect that keying material. And so when we do the crypto Ike V2 proposal, and then give it a name, think of the proposal as similar to an Ike V1 policy, the ISAMKP policy that we would create. So now let's go ahead, and there is actually a policy that we need to create. And so let's say crypto Ike V2, and we're going to say policy, and we'll name this CA2NY, and I'll just say POL for policy. So California to New York policy. And again, the policy is probably the easiest thing to configure here because all we're going to be dropping into the policy is we're going to be referencing the proposal, right? So the Ike V2 policy, it's really just sort of defining the Ike V2 proposal, right? And so that's what we're going to be doing with the policy. And so let's go ahead and drop the reference in here. So we would say proposal, and what's the name of our proposal? CA, whoops, and let's not do, oh, there we go, 2NY and proposal, right? PROP is what we used. And if we were to put something in here that didn't exist, you can see it's going to tell you, hey, that policy doesn't exist. So they made it a little bit smarter on the configuration. And again, configuring the crypto, especially if you're doing it in a lab scenario where you're being tested, it can be a little bit stressful because there's so many different options, right? And you've got to remember sort of the different ways to do things. And so it's nice with the Ike V2 interface here with the Cisco routers, how it sort of helps you out. So this just saved me from a typo, but we got it in there the first time. And in fact, if it's already in there, it's going to tell you, hey, the policy already has that name set. All right, so we've got the proposal done. We've got the policy done, right? So now let's take care of the key. Remember we did the crypto ISAMKP policy when we were doing Ike V1 for phase 1. And so we would do the policy, and then we went ahead and set that pre-shared key. Although remember, we define the pre-shared key in the Ike V1 policy stanza. We didn't do that in our proposal, and we didn't do it in the policy. It's with the Keyring that we're going to do it. And this is where it allows me to define a local and a remote pre-shared key so that I can have different pre-shared keys on both ends and still have the tunnel come up. So let's do our keyring. Again, crypto Ike V2. And again, I love how they have us type in this Ike V2 keyring, and I'll just say R1CA-key. Or actually, let's just go R1-key. We'll not make it too difficult on ourselves. Okay, so here we are in the keyring setup. So I'm going to say, who's my peer? Well, it's going to be router 2 in New York. And we can just go ahead and, again, so what this is the peer block. So what if router 1 was also trying to set up an Ike V2 security association and an SVTI to routers 3, 4, and 5? This is where I would come in and say peer router 2. I put in all the settings for router 2. And then I would come in and say peer router 3, and I would put in all the settings for router 3, and peer router 4, and put all the same settings in for router 4, right? And so that's what we're going to do here. So I'm going to say peer, and we'll just call this R2. And actually, we can say R2-NY, right? So that we're being very specific. Now, I'm going to set the address, right, of the peer, and it's the outside publicly routable IP address of router 2, New York. And here's where we get into the pre-shared key. So the local pre-shared key, I'll use ABC123. But on the opposite side, on the remote side, let's use XYZ789. Right? So what we're saying is locally here, my key is ABC123, but I'm set up now to look for XYZ789 as the pre-shared key that's going to be coming off of the other router. And so again, this is similar to when we do the crypto ISAMKP key command, except we're just putting it inside of sort of a configuration stanza and defining it by peer, or organizing things by peer. All right. So now that is done, we'll pop out here. And now we're going to set up an Ike V2 profile. And here's where we're going to say that we're using pre-share authentication locally and pre-shared authentication remotely. So we set the key up, and so these two stanzas are tightly coupled and synonymous with what we saw with the ISAMKP key command, except here, again, we've got a lot more options that we're dropping in because there are more options. Remember, the authentication is now unidirectional, right? So let's go ahead and say crypto Ike V2 and profile, and we'll just call this R1 prof, R1-PROF for R1 profile. Now, again, take a look at this. So profile must have local and remote authentication method, right? And that's going to be that authentication remote pre-share, authentication local pre-share, and then a match identity or match certificate or match any statement. And here's where this profile, I can set it up so that we're matching a specific address, or I can leave it wide open so that we're pretty much matching anybody that would like to try to negotiate a security association with us, right? So let's go ahead and start out with the match identity, and let's put in the remote identity, or the remote address is what it's going to be. And so I'll say address, and here's where we're going to put in the 209.165.20.222, right? And so we've matched the remote, it's a match remote identity, and then I'm going to put my local identity in here, right? The 209.165.10.111. Now, this, I keep forgetting to put address in there. Let's put address. There we go for the address. And now we're going to go ahead and say authentication for the remote, is going to be a pre-shared key. And then the authentication for the local router is also a pre-shared key, because again, we could be using signatures to do it. So, but here, keeping it simple, pre-share key. All right, because now we need to reference the keyring, right? So it's a local keyring. And what did we call our keyring? I think we called it, if I was to scoot back up here just a little bit, and we named our keyring. It's going to be right before that. R2 is the peer, R1-key. All right, so R1-key. And again, this is telling the profile where the key ring is, which is where those pre-shared keys reside, the ABC123 and the XYZ789. So that takes care of the key ring. So let me pop out of here. So at this point, right, the analogy that I'll draw is that phase 1 is complete, right? Everything we would have done for phase 1 with Ike V1 is now complete. Now, we're going to move to what synonymously the analogy is what was phase 2, right, with Ike V1. And this is something that is familiar to us, right? Because the configuration is the same. Crypto IPsec transform set TFS. And here, right, remember, now we're not dealing with keying material anymore. Now we're talking about the payload, the data, right? The cargo. How are we going to protect that? Well, we're going to do the exact same thing. I'm going to say esp-gcm, right? We're using a combined mode cipher, 256-bit. And if that's the case, do I need to put one of the integrity algorithms here? What if I tried to say ESP-SHA-512, right? And you see what it's doing, right? It's not doing the completion. So let's type it out, HMAC. What's going to happen here? There's an error because we're using the combined mode cipher, which is Cisco best practice recommendation is at esp-gcm 256. That's what we should be using, right? And so when I hit enter, it works, right? But I can't put in an integrity hashing algorithm because I don't need it. It's built in. That's that combined mode. So let's go ahead and say mode tunnel. Again, that's our default, right? But we'll drop it in there anyway. Okay, so we're going to pop out of here because now we're going to create an IPsec profile. And a lot of learners, again, if you're following what we did in Ike V1, when we created the crypto map, right? And then we would define a few things in the crypto map. This is kind of similar. So we're going to say crypto IPsec profile, and I'll just call it IPsec-PROF. Excuse me, for IPsec profile. Now, what are we going to be doing in here? Well, we're going to set a few things. Again, you could throw a description in here and say router 1 to router 2, whatever you want to put. But the two commands that we really need here is we're going to go ahead and we're going to set the transform set, right? That TFS that we just created, right? Which was the phase 2. How are we protecting the cargo using that combined mode encryption algorithm? And then we're going to set the Ike V2 profile, right? So we're tying in the Ike V2 configuration under the profile stanza with whatever the name was, which I am now drawing a complete blank on. So let's do a quick do show run, include PROF, because I'm pretty sure that was the end of the name that we used. And it was whoa, did I say IPsec? Ike V2 profile. It should be R1 prof is set Ike V2. Whoops, sorry. I got the K in there. So we're going to say set Ike V2 profile. And again, profile name that we used is R1-PROF. And that's the IPsec profile below it. So we want the Ike V2 profile. All right. And so we're going to set that. Now, something else that we might want to set in here is this perfect forwarding secrecy, right? And again, we would be defining a Diffie-Hellman group here. And what is this for? Well, this is sort of in addition, when a rekey takes place, this is going to be the perfect forwarding secrecy is going to be involved to protect that rekey. And so if I said PFS, you can see we're going to have a whole bunch of Diffie-Hellman groups. And again, we'll take group 21, right? And so we take care of that. And that is it for the profile. That's it for our configuration. And so if I was to say end and we do a quick show run here, and again, that's it for the crypto Ike V2 configuration. So let's take a look at what we've got. And I think you'll like the way that this is kind of grouped together. So here's my proposal, right? So I've got an Ike V2 proposal. I've got an Ike V2 policy, which just simply references the proposal. I've got an Ike V2 keyring, which again, I can put multiple peers in here if I didn't want to have, or if I didn't want everybody using sort of the same settings, I can define multiple peers. And so we have a keyring, Ike V2 keyring, and then we have a crypto Ike V2 profile, R1 prof, where we identify the local and remote nodes, and we identify how the authentication is going to take place. And where's the keyring? What's the name of the keyring that we've defined where all the keys are going to be stored? And that's right above us here. Then we do our phase 2. We get the transform set, right? And the crypto IPsec profile. Now, that crypto IPsec profile is what we're going to put on the tunnel interface. So let's make that tunnel interface happen here. So we'll go into global config, interface tunnel 0. And remember, no GRE involved here, right? Because tunnel mode GRE, you're not going to see. You're going to see the tunnel mode IPsec, right? That's what we're going to be using. Okay, so the first thing we'll do is we'll put the IP address on here, and this is router 1, so it'll be .1. And then we're going to go ahead and say, let's set our MTU to 1400 and the IP TCP adjust MSS to 1360, right? 40 bytes lower for IPv4. And then we've got the tunnel source is gig01, the tunnel destination, and this is sort of old hat here because we know it's that publicly routable 209.168.209.165.20.222. And now we get down to those last two tunnel mode commands, right? So it's going to be tunnel mode, where are we at here? IPsec, that's right, I had that in there. IPsec IPv4, right? And so this gives me the SVTI. Now let's protect it. Tunnel, oops, I keep messing that up there. Tunnel protection IPsec profile. And this is the profile that we created. Remember I said crypto IPsec, IPsec-prof? That is what we're pulling into play here. Now, if that IPsec-prof didn't exist, it would tell you that it didn't exist. And so that's it, right? So it's not that much difference. Let's go into privilege exec here. And now, again, nothing set up on router 2, so we don't have anything working yet. Let's come over here to router 2 and let's walk through a little quicker now, sort of the same thing. So we'll say crypto Ike V2 proposal and what just say R2-prop. And remember, here it's where we're going to set the encryption, and we'll do the best that we can here with aes-gcm. And again, needs to match the other side. We don't need integrity, right? Because that's already been taken care of. The Diffie-Hellman group we used was 21. The pseudo-random was SHA-512, and let's make sure we got everything here. So we got the encryption, we got the Diffie-Hellman group, and we got the PRF. Again, don't need the integrity, combined mode encryption algorithm. So now we can punch out of here. Our proposal is complete. So now we'll say, sorry, getting ahead of myself. Crypto, Ike V2, proposal policy. So we'll say policy, and we'll just call it R2-POL for the policy. And again, the policy is referring to the proposal, which we have as R2-PROP. And again, if that didn't exist, it would say that that didn't exist. Now let's do our keyring. And so we're going to say crypto Ike V2 keyring, and I'll just say R2-keys. We'll do keys. And then our peer is going to be router 1. And I don't know, I can't remember if I put in here router 1-CA. We'll go router 1-CA. And then I'll just say address is 209.165.10.111. And how are we going to do this? We're going to do a pre-shared key locally. And so what is router 1's pre-shared key? It's ABC123. And what is my pre-shared? I'm sorry. I'm not on router 1, so let me rerun that command again. So my local key is XYZ789. And then the pre-shared key that's remote to me is ABC123. So again, a little additional security that can be added in there. And let me take a look at this do show run section key. And I want to make sure that we've got local XYZ789 remote, so we're good to go there. So let's punch out here. So now let's do the crypto Ike V2 profile, and we'll just call it router 2-PROF for profile. Again, match, identity, remote address, and it's going to be 209.165.10.111. And then we're going to do the identity for the local address, which is going to be our 209.165.20.222. Keep forgetting to put address in there. All right, and then we're going to do authentication remote is pre-share, right, because we're doing pre-shared keys. Authentication local is pre-share because we're doing pre-shared keys. And then our keyring local is R2-keys. There we go. And so, again, you can think of it as, okay, all of our phase 1 stuff, like when we did Ike V1, all of that is done here. So we'll say crypto IPsec transform set TFS, and we're going to use the best we can, which is going to be esp-gcm 256, and that's all we need. We'll say mode tunnel. And now we're going to create the crypto IPsec profile. So crypto IPsec profile, and we'll simply call it IPsec-prof. And it's in here that we're going to go ahead and set the transform set to TFS. We're going to set the Ike V2 profile to IP. Wait a second, I'm drawing a blank all of a sudden. Set IPsec Ike V2 profile. I'm going to have to come back over here and take a look. Doing this from memory is never a good idea. Let me see. So we'll say show run include prof. And I think it's just R2-prof. Yeah, and that's what it should be, is just R2-prof. So let me pull this back and let me double check real quick here. Do show run section include prof. I think I called it R2-prof. I did. Okay, good. All right, so set Ike V2 profile and R2-prof for the profile. And so then that's it. That takes care of what we used to call an Ike V1, sort of our phase 2. And you can think of what we just did right here. The IPsec profile is kind of like a crypto map a little bit, right? Okay, so now let's get into interface tunnel 0 and let's finish up this configuration. We'll get our IP address in here, 10.0.0.0.2. And it's a /24. And let's go ahead and set the IP MTU to 1400 for making sure we don't have any fragmentation. Then IP TCP adjust MSS, right, for the maximum segment size, 40 bytes less than the MTU. And then we'll get the tunnel source is gig02. Tunnel destination is going to be that 209.165.10.111. And then here we go. Tunnel mode IPsec IPv4, and then tunnel protection IPsec profile, and then IPsec-prof. Now, before I hit that, is anything working right now? Right? Nothing's working. And again, remember, we haven't set up any routing yet. So, did the tunnel come up? And here's where we can run some commands like show crypto. And again, I like it. It's show crypto Ike V2, right? So instead of having to remember, is it ISAMKP or is it IPsec? Am I doing phase 1, phase 2? It's show crypto Ike V2, and we can take a look at all kinds of different stuff, right? So I can take a look at the security association, and here it is. And you can see it's got all of our settings in here. Diffie-Hellman group, the whole 9 yards. How are we doing authentication? Pre-shared key, right? And it shows that we've got that security association there. And let me go ahead and say detailed, see if it gives us any additional information. And take a look at this, right? So we get a lot of nice information in here. The local ID, the remote ID. NAT-T is not detected, right? Because we're not doing NAT. So NAT-T not detected, initiator of the SA. So router 2 is listed as the initiator of the SA. Can I ping across the tunnel? Can I ping over to router 1? Outstanding, right? So router 2 can ping router 1's tunnel IP, and so you can see that we can define different pre-shared keys because, again, of that unidirectional authentication. Well, if that's up and we've got the tunnel up, now I could do static routes, but no one likes to do static routes, right? Let's run a routing protocol here. And so we've not shown a lot of love to EIGRP. So let's say router EIGRP, and we'll just simply use 1. And we'll say EIGRP router ID, and we'll set it to 0001. And then we'll throw our network statements in here. So we need the network for the 192.168.10.0. And I'm going to hit enter because that's a classful network boundary there, so I don't need to lay a subnet out for it. And then the tunnel interface, 10.0.0.1, and I'm going to lock that down like that. And so that would take care of the EIGRP config here. Let's come over to router 2, and let's jump into router 2's global config and then say router EIGRP1. Remember, the EIGRP number that I'm using there, that's the autonomous system number that has to match for the adjacency to come up. EIGRP router ID 0002. And then we'll drop our network statements in here for the 192.168.20.0. And now here's where all the fireworks will start. Network 192.168.20. Oh, I'm sorry, I need the wrong network. I want 10.0.0.2, and that's that interface. And so we should see the EIGRP adjacency pop up. There it is, new neighbor, and look at that. And now we have connectivity from California to New York encrypted using, and I'll go ahead and use the expression military grade encryption, right? Some really, really nice encryption settings, all of which, with the exception of the Diffie-Hellman, which is not sort of next-gen encryption, right? Remember, the Diffie-Hellman is, they're not quantum computing safe, right? But again, it's definitely going to take some work to hack that and figure out what's going on there. So we've got great encryption set up here. The best that we could do with the iOS that we have, and it's all Cisco recommended next generation encryption, and that is Ike V2. So again, one last look here. Let me show you the configs. Whoops, sorry, I'll say show run, and we'll come down to the stanza where we have the proposal and then the policy. And remember, combine mode encryption algorithm, so we don't do integrity. We've got our keyring. We've got our profile that references the keyring, saying that we're doing pre-shared. Then we've got sort of our phase 2 crypto IPsec transform set. And then we create a profile, because that profile is what we apply to the SVTI in order to protect the traffic that's in that tunnel. And that is SVTIs using Internet Key Exchange Protocol, Ike version 2. All right, well, hopefully you've got a much better understanding of the history, right, from the crypto map to the GRE over IPsec to the SVTI, Ike V1 to Ike V2, and we've seen a lot of different ways to do things here. So again, if you've got some routers, experiment. This is something, the Ike V2 is something you're not going to be able to do in Packet Tracer, that's for certain. But again, it's good to know, because this is how you should be laying out your greenfield environments. All right, well, thank you so much for watching, and I hope to see you in the next video.